So winter is quickly approaching and power outages and the heavy storms are going to be coming. So, I have this backup generator I use to hook up to the house, and you're supposed to start it every 2 to 3 weeks, but, kind of time gets in the way and you forget. And the worst thing that happens is these batteries start to drain. So, today I'm going to make a quick float charger for it using a little regulator board that's a DC-DC converter. It has a National Semiconductor LM2596 on it, and we're going to set it to regulate at 13.8 volts so we can leave it hooked up to the battery all the time, so we don't have to worry about having a dead battery when we need the generator at the most dire time. So let's get started with that. So these are the basic items you want to build a regulated float charger. And the first one is this little board that I got off of eBay for like $2.50 from China shipped. If you go onto eBay and you look up a LM2596 DC-DC, there'll be hundreds or thousands of these listings available. This one actually has a nice display. It shows you the input voltage and output voltage. This one turns the display on and off. This one switches between input and output. And to change the regulated voltage, you adjust this little potentiometer here. The next item out of the junk box, I have this old wall wart that does 12 volts at 500 milliamps. It's a AC to DC adapter. And the nice thing about these old ones is there's just a transformer in here with a bridge rectifier or even a half-wave rectifier. More than likely it has a bridge in it though. And it just feeds into a capacitor and it will just float up to about 16 volts without a load on it. The newer wall warts are these really lightweight ones, and they're really thin. They're usually a switching power supply in here, and they're regulated. So what you need to do is find one that does about 15 volts out minimum. The DC-DC converter will take up to a 40 volt input, and then you can regulate it from anywhere from 1.25 to 37 volts with this potentiometer here. And so let me put this together and we'll hook it up. On most of these wall warts, the wiring is identified on the DC ones with a little stripe or a white line down the positive side of the lead. But you always want to verify that. So I've stripped the wiring back on these leads and I've plugged it into an outlet. And if you put the negative lead of your multimeter on the black wire and then the positive lead of your multimeter on the striped wire, you can see that this wall wart puts out about 17.7 volts even though it says it's a 12 volt wall wart. And these are the older wall warts and they do that. But this is what we're going to use to verify that we're plugging the correct wiring, the positive and the negative, into this so we don't destroy the module. So now I've unplugged the module from the wall, and I'm going to connect the striped lead to the input plus on the module. Screw it in, and the negative lead to the, and you saw the LED flash up there because there's a capacitor in that wall wart, and it stores a little energy. And that discharged when I just hooked this up. So the next thing we want to do is just plug this into power, and you can see the display on the converter is lit, and the camera is causing it to strobe, but my eyes can't see that strobing, but on the camera you can. So adjusting the voltage is the next step you want to do, and you want to adjust it for about 13.8 volts. So if you turn this one counterclockwise, it brings the voltage down, and we're right at 13.8 there. It's kind of hard to see, but we'll verify that with the multimeter just to make sure that the module we have is actually putting out what it says it is. So what we have there is 13.9. We're going to want to use the multimeter to tweak it down just a little bit. And so I've adjusted it for 13.83, it looks like, 8.2, 8.3. And the display on the module says 13.7, which is fine. It's just a good indicator, let me know that it's on. And then if I switch to the input side, you can see it's at 16.6. And then back to the output side, it's 13.7. And I'm just going to put these alligator clips onto this so I can just clip it onto the battery, but permanent installation would be nice where I just wire this up and just plug it in and just leave it set up to connect to the battery whenever it's just sitting here in the garage. So I've just hooked up the regulated float charger that we just made, and it is displaying about 12.4 volts, 12.5. So it's actually measuring what's at the battery voltage minus the drop of these wires here. And the module will try to go to compliance at 13.8, which is what we set it for with the potentiometer. So if you leave it on here, it'll just charge up to the 13.8 volts, and then it will stop voltage wise, and it'll just keep trickling current in at that point. And it should drop somewhere around 10-20 milliamps for this size battery. And at the 13.8 volts, you should be able to leave it connected for weeks on end, maybe months on end, and it should never harm this type of battery, this sealed lead acid battery. So I'm just gonna roll this guy back into the garage and get him ready for the next power outage we have, and just leave this float charger connected to it. So I hope this helps you with building a float charger for your sealed lead acid battery application and maybe your generator. And thanks for watching.